Yeah. You rolling? Hey YouTube, it's Petey Two Finger here. We've been shooting a couple already and redoing them. The cat's crying. So.
You can stop crying now?
So, how do you do a current draw test? And what that is, a mAh test, milliamp or amperage test. It's, here's the battery, here's the pedal. I'm got a new rig and I'm going to use this chorus pedal as a splitter because there's going to be 2 amps. So it's rather than building a signal splitter, which I very well could, I'm going to go ahead and just use this. That's what I'm doing for now. So I was thinking I should test this chorus because there's a chance it's digital and it's going to draw a real lot of current. The thing about guitar pedals is, like the old fuzz pedals, the stuff that's transistorized, the analog circuits, they tend to draw a lot less current. So what you could think of as current is, like this battery's full, let's say it's 1,000 milliamps full. And every time you use it, it's draining a little bit. And then when it gets down towards the bottom, the voltage is really going to drop off. It's going to go from 9 volts down to 7, down to 6. And it's not going to power the pedal anymore. So that's the milliamps. When you look at a power supply, a wall wart, it'll say 9 volt DC, 300 mAh. And that stands for milliamp hours, I think milliamps. 1,000 of those mAh is 1 amp. So you're familiar with amp. You hear amp more often than you do milliamp, some of us. And you could consider that amperage or milliamp or current rating to be the capacity of the battery. Now, when we're hooking stuff up, if let's say I have a 9 volt DC 1000 mAh battery and we find out that this only draws 300 current, am I going to blow up? Is that 1000 going to and smoke this? No. Now 1000 is going to sit over here going chugga chugga chugga, and this chorus pedal is going to go beep beep beep. It's just going to take 300. So there's going to be 700 excess mAh sitting, and that power supply is going to run very well because we're only using 1/3 of its capacity. So that's something to consider. If you go under, like let's say this ran at 300 and I used a 200, well, for one thing, this pedal wouldn't be getting all the current it deserves to run properly. So it's going to affect the performance of the circuit. And for 2, it's going to put a strain. It's going to get hot. The power supply is going to get hot. So that's what you don't want. You don't want to go under on the number, but you can go over. And what this is helpful for, you think, well, why would I ever want to measure my pedals? Petey's tripping. Well, if you're designing a pedal board and you've got power supply that has multiple outputs on it, and it says maximum 1 amp per socket, or whatever they are, I would be adding up my pedals so I don't go over on each socket. So like, oh, this one takes 300, this one takes, it's digital, it takes 800. So yeah, I can't run that 300 with that 800 because it's going to draw too much. So as a rule, the older analog stuff is low. The stuff that runs off of transistors, and the op-amp stuff is low. It might be a little higher than the transistor stuff, but the digital stuff is where we get into, you know, if you've ever bought a digital pedal off of Amazon and it came with a battery, and you put that battery in and it worked for 20 minutes, and you're like, why did they even give you a battery? Well, they give you a battery so you can test it. So like in my case, if I buy a pedal, and I've gotten pedals, they say this battery won't last very long. I don't even test it. I save that battery, I'll put it up on the shelf where I keep my 9 volts and use it for, you know. So back to enough talking, right? People always get mad at me in the comments section because I talk, and I say, if you don't have the patience to listen to me talk for 10 minutes, you might want to find another hobby. Especially when you work on something for 3 hours and then it doesn't come up. And you have to troubleshoot it and you have no idea what you did wrong. That's going to try your patience. So, and believe me, it happens. The more you think you did a perfect job, the more errors there are. So in order to do this, we need a cable because without the cable, this pedal doesn't turn on. So that's very important that we have a cable plugged in to the input or however you activate your pedal. You can go in through here, like if the pedal doesn't have one of these, you can use a 2.1 mil DC cable and cut it. You need a meter that has that test on it. Our meter I know because it says DC 10 amp and then DC MA. And that's the same test, it just moves the decimal point. So whenever you're going to do a current test, you have to move this over. And I know that because see where that yellow is? Those things say the same thing. And if you forget, the test won't work. It'll just say 0 until you move it over and then it'll come on. So we've got our test probes. Our little guy is moved in the right socket. Our test probe is set up. We take the positive lead, put it on the positive side of the battery, which is not the grabby guy. It's the one that looks like a normal nipple. And plug that into the grabby guy, because that's where it plugs in real life. That's the positive terminal on the pedal. They're opposite because they mate. And then what should we do? I'm gonna you could do this one of two ways. I'm gonna hook the negative up to the battery actually, and then we're gonna take that negative. This is where you do rev pol, reverse polarity. You hook that up negative to the positive. Let me go ahead and set this over to the DC milliamp. It is DC. How about that? And we go ahead and make contact, and we see it spiked and went down to 0.16 milliamp. How about that? So now let's move that over to that 10. 0.016 amp. So what that tells me is it's 16 milliamp is what this is. Or wait a minute. With the decimal points, I'm getting confused. So 0.016 amp. So 1 amp. It's 60. It looks like to me this is 16 milliamp is how this circuit reads because of where that is. So that tells me that this is it's drawing 16 milliamp. Because 1,000, there was 3 zeros there when I had it on the 1 amp section, and it was 0.16. So yeah, it's with the milli means 1,000, so it's 16 milliamps is how much this pedal is drawing when it's idling. Now, if we were to Okita, if we are to hook it up again and run audio through it, would that go up? Is it different? Is it a lower setting when it's off and it's not got any audio through it? We can go ahead and test. It would be an interesting test to do because I know with amps they have this quiescent current, which means when it's not passing any audio. So here, let me hook the power up. You have to have the power hooked up and then hit the button to turn it on. Yeah, no, it looks like it's about the same. And because this isn't an amp, it's not going to draw any more current. I can just tell you, I'm not going to go ahead and do that test. I would seriously be surprised if that went up. So that's how you do the current draw test to determine how much milliamps your pedal draws. Before you go through this actual test, I would encourage you to Google it. You know, so you type in Boss CEB space -3 bass chorus and then current draw, and you very well someone else may have already supplied you with that information. So this is how you test for current. It's a little bit goofy because you have to move the multimeter over. So I figured I would make a quick video on that, although I know I've done this already on this channel before. So, all right, you guys, I guess I'll talk a little bit more. The idea with this was I had built a Friedman BEOD, and I also had a Tom Scholz Rockman Guitar Ace, and it really sounded really good on this amp I built as a front end distortion preamp type of an idea, this Rockman. And I had already ordered this Uji, the pedal, Friedman, and for that same purpose. And then we couldn't find the Rockman for a while. It was kind of lost. So we found it after I ordered the pedal, and I built the pedal and compared them, and I really liked the Rockman sound better. And that's because what I'm going for, it's a wet, dry, wet rig, and I already have a real lot of gain on the patches on the other device, which is a Zoom G3 or a Zoom G1. So yeah, the Rockman won out. But either way, for my test, I needed something to split the guitar signal into two and run one cable to the Rockman into the amp, one cable into the Zoom into power amp and a pair of PA speakers. So doing all that, I did the test today, and like I said, I very well could build a signal splitter. It's just JFET or an op amp splitting the signal, and that would actually probably use less current. But right now, buying the chassis for that and all that, I probably could use something like a jewelry box, but I really don't feel like doing it when I can just grab this and it's only draining 16 milliamps. That means I can run this off an internal battery, not really worry about it. It should last a long time. So that's current draw test. That's why I did it. And thanks for tuning in. Why don't you go ahead and subscribe? I try to do helpful stuff on this channel, like this video, in between me talking about stuff that I find interesting, recommending stuff that I think is cool, which is music or movies or television shows, light on the TV shows. And then there's music, and sometimes I'll do like interesting documentaries. The Acid Casualty series is always a crowd favorite, or people get upset about those videos. I have a sister Vimeo channel where stuff lives that if YouTube kicks that video off for whatever reason, I might put a copy of it over on the Vimeo. So yeah, thanks, and I'll see you around. Peace.